Hello! It's been a while since my last video, and that's because I've been working on something rather big. So, what's happened? Well, my lab is in chaos. As you can see, there is stuff everywhere, and my desk is no better. I have been writing books. I went from the first book, I made a set of magazine articles, and now I've made this book, which is Learn Robotics Programming, 2nd edition. It comes with the instructions to build the robot that lives in this box. So what have we got in this box? It's lived in this box for a good couple of years with some, you see, some stuff about Orion robots and some recognisable stickers from Pimeroni. I rather do like Pimeroni. I've been corrected on that. So here is the robot. Now I have had to collapse the antenna. I'll pop that back up in a minute. Let's have a look at the features of this robot. So first, it is based upon a super affordable, very well available chassis. I've tried to do that to make sure that anyone can replicate the results and anyone can make this robot. So I've not used any super specialist, hard to find, weird parts. You can get this, eBay, Amazon, Alibaba. You can probably get it from other random places on the internet. There's lots of other roboty places as well. Again, it comes with these motors. These are, I think, the formal, more expensive brand is the TT motors, and Adafruit do the really good ones. There are tons of places that do cheaper ones. One thing to note is not all of them come with the cables soldered on, so you may have to solder cables on. It's better if they come with the ones with the cables on, but okay. There will be some soldering later in the book, but I have tried where possible to use modules that don't require soldering, that let you just get in there and do it. There is a section in the book on making soldering joints, so it's not anything to fear. Okay, so what else have we got? Well, so there's a battery pack here, and the book explains why there are 2 battery packs. So there's one for motors, one for all the logic and sensors. It would have been motors and lights. I've actually got one, the light thing I'm using, which is the Pimeroni LED shim. Doesn't take up much power at all. What else have we got? We've got a camera on the front here on a pan and tilt mechanism. So you'll learn in this book how to program servo motors so you can move the camera around, so it can both move left and right, and it can go up and down, and you'll program things that will make it go in circles. You'll program things to make it search for things. So in fact, it'll search for a face. And although that sounds complicated now, once you've gotten through the book, you'll understand the mechanisms to do so. So how to scan for faces and how to use a PID algorithm to make it actually use the motors and track the face and keep track of where a face is in the room. As also, you can amusingly exchange it for cat faces, which confuses cats quite a lot. The other 2 things here, and you see these on the front of robots, and they look curiously like eyes. These are distance sensors. Again, very available. You'll find them on pretty much all of the places you can get electronics on the internet. And they measure how far something is away. And again, I'll show you how to program to work with these, how to use them to avoid objects. And even how to set one of these up with this pan and tilt and do a sonar scan of your room so you can see how far things are away. Go into things like the motor board here, which is how you control motors and servos from a Raspberry Pi. So this is a Raspberry Pi 3A+. 3A+, basically there are many different Raspberry Pis. You've got the Raspberry Pi 0 and 0W, which are very small and cheap. You've got the Raspberry Pi 4, which can have, lots and lots of memory. It's very powerful, but it's also a bit power hungry. And on a robot, you probably want to get as much playtime as you can. So there's a compromise to be had. 3A+, for me, it's a good compromise. The book explains why and how you can make these choices yourself. There's obviously a bit of a wiring board here just to wire sensors and a power switch in. And you'll see that explained in the book, how you wire it up, how you program it. And what other sensors we got? Oh, we've got encoders. So just under the pie, here we go. Hold on, let me see if I can angle that just right. So encoders is a way for your robot to detect how far it's going. It counts notches on these. And again, the book will show not just how to count them, but how to take those counts and track how far the robot has gone and to calculate turns from them. So you can say, okay, if I want to turn 90 degrees and I know the shape and size of my robot, then when I've counted these many pulses on each side, I know how far I've gone. So what about the book itself? Well, let's get a closer look. I'll just put the robot back in. Oh, sorry, what was this hanging off the side? Let's put that back on. It doesn't fit while it's in the box. I'll just bolt that in there. This is the IMU, the Inertial Measurement Unit. It integrates a magnetometer, which acts like a compass, an accelerometer, which can tell basically which way down is, or if the robot's being thrown, but I don't recommend throwing robots around the room. And also it's got a gyroscope, so it knows how far it's moved in any angle over time. And so you can use those to start to determine basically how a robot has turned in an absolute position. In the book, it goes into how to use it to do a behavior that always goes north. So I talk a bit about behaviors. So you got your sensors, you got your motors, but you want to integrate them and make them do something interesting, like either make you a nice display or have the robot track something or move in some way, follow an object around a room. You can get it to follow a coloured skittle around the room. And I call those behaviors, which build on top of the other layers of the robot. So let's get into what's in this book. So this is the first time I've had the book in my hands, the second edition. It's quite nice to have it in print. What do we have? So talk about where you might find robots in your home, what devices you might come across every day and might not have thought of, but they display autonomous or automatic behaviors. Now, they aren't necessarily doing machine learning, they aren't necessarily doing AI of any kind, but they are doing the kind of control circuits that you'll need to get familiar with, and you will get familiar with by basically working through the robot examples and tests and programs and things in the book, and maybe taking them a bit further. The book is full of parts at the end of each chapter that challenge you to go a bit further than the book has taken you, to kind of suggest, well, you've learned this skill and this skill, maybe you could put them together, maybe you could try these further things. So it doesn't just take you to the point where you've built that robot, it takes you to the point where you can build that robot and more, and think of your next robot, plan further robots, maybe even a Pi Wars robot. Pi Wars, a Raspberry Pi Robot Wars, autonomous robots and some manually driven robots. You get mazes, popping each other's balloons, driving around obstacle courses, that kind of thing. So the book has step-by-step instructions on assembling parts of the robot. It has sections of code, so testing an LED, because first time you've connected a strip of LEDs, the first thing you want to do is to test one LED. Code is all Python 3. Diagrams showing how the system connects to each other. So obviously you can see that electronics connect, and there's diagrams for those, but also software components. So some of the code gets to the point where we're using services online. For example, we have a speech control agent, which means you can talk to a robot or talk to a controller for the robot, and it will decode what you've said, and the robot will move into response to what you've said. Mycroft, tell the robot to drive forward.
Robot is starting.
It's kind of fun. Not recommended for a stop button. It's good for getting things started, but for getting things stopped, probably better to have a stop button. But that's okay, because it also shows you how to connect a phone. So let me see if I can find the example. Oh, hold on. That's an exciting one. that's you turning your robot into a compass using the IMU, and you can actually see the angle you're tilting the robot, so you can lift it and move it and turn it, and it does so on screen, showing you a compass readout, where the robot is, and graphs of all the axes. Something you build in the IMU chapters. Let me see, choosing a controller, as in a control pad. So there we go, it shows you how to build this. So a smartphone app to drive and control the robot. Comes with a menu system to actually launch different behaviors that we spoke about. So you can use your phone to entirely control it once you build it, and you'll do so building skills to build other robots controlled with phones. So other robots in my robot cupboard, I've got a spider robot, I've got robot arms, I've got all of these things. I like to control them all from my phone if I can, because in times that weren't pandemic times, which has made things a bit interesting recently, I would go to events and I'd bring many robots, and I found, well, going in from my laptop to log in and start code on them or something like that was quite frustrating. And some of their behaviors were completely automatic, but I don't want to switch behaviors or drive them. So having them all drivable from a phone, so I can turn up an event and just switch the phone to the different robots, kind of makes it fun. So also diagrams like this, which show the chain of things you would do to an image, so your robot can turn that image into movement information. So it knows, if I'm going to follow this thing, not only do I need to detect it and figure out where it is in the picture, but what movements do I need to line it up to keep it in the middle of the picture? And that's also explained in the visual processing chapters. We follow nice thick line with it as well. We show how to build a very simple, cheap and cheerful line following line. I think it'll be great fun for anyone to pick up this book on robots. If you've never used a Raspberry Pi, it'll take you through the very basics of installation of a Raspberry Pi. If you have used one, you'll get through it a bit quicker until you perhaps get to some of the more interesting robot chapters. So this one will kind of take you from, maybe I have held a screwdriver and maybe I have written a couple of lines of code, you might know what an if statement is, to having worked with OpenCV, having built smartphone enabled web apps with touch, and having built a speech control agent on a real robot. So over the next few weeks or so, I'm probably going to make some other robotic videos, either featuring this robot or some of the other goodness I've been working on. I've been having some fun with this big guy over here as well, so I'm going to do a video featuring this thing and stuff I've done with it, and perhaps connecting some other robot arms, because arms are fun. If you do have any questions, let me know. I will have links in the description on where you can buy this book. It is now on pre-order. It's in pre-order in pretty much every country as far as I know. I guess, well, go make stuff and be awesome. Especially make robots. Yeah. Bye. Sound test 2. 1, 2, 3, 4. Who's that knocking on my door?